When you combine 5 grams of hydrogen and 10 grams of oxygen, you end up making 11.3 grams of H2O. And the way that I know that is that I understand limiting reagents and stoichiometry. And by the end of this video, you'll know exactly how I figured that out. You see, in real chemistry, one reactant always runs out first, and that's what's known as the limiting reagent. And once that limiting reagent is gone, the reaction stops, no matter how much of the other reactant remains. And the tricky part is that it's not always obvious which reactant in your reaction is going to be the limiting reagent. And guessing wrong is going to lead you to get the wrong answer on your chemistry problems. And make sure you stick around to the end, because then I'll give you some practice problems that should help for your next exam. Conceptually, what limiting reagent means is which of the reactants is going to run out first when making new products. A simple way to think about limiting reagent is to think about how you make grilled cheese sandwiches. When you make a grilled cheese sandwich, you use 2 pieces of bread and you can use 1 piece of cheese, and that is going to allow you to make 1 sandwich. And for that, we can think about that recipe as being our balanced chemical equation, where we're taking 2 pieces of bread, 1 piece of cheese, and we're making 1 sandwich. Now we can use stoichiometry to figure out how many sandwiches we have. So if I go into the pantry and I see that I have 8 pieces of bread, then I can figure out, based on how many pieces of bread I have, how many sandwiches can I make. So let's say that I have 8 pieces of bread and I use the stoichiometric factor that I can make 1 sandwich for every 2 pieces of bread, and then I can find out that that means that I could potentially be making 8 times 1 divided by 2, which is going to be equal to 4 sandwiches. However, if I go into my refrigerator and I see that I have 3 pieces of cheese, then that means that I'm not going to be able to actually make those 4 sandwiches. Because remember, I need, for every 1 sandwich, I need to combine 1 piece of cheese. So therefore, I could only make 3 sandwiches based on how much cheese that I have. And this means that the cheese is going to be my limiting reagent, because it limits how many sandwiches I can have, and I'm going to be left over with excess amount of bread, because I only need 6 pieces of bread to make 3 sandwiches, even though I have 8. And therefore my limiting reagent is going to be the cheese, because that's the reactant that gets used up first. Now let's talk about the steps that will make you successful in determining the limiting reagent. The first thing that you need to do, which is the same for all stoichiometry problems, is write out a balanced chemical equation. So make sure that your chemical equation is balanced, because those stoichiometric factors are going to be super important when determining the limiting reagent. Once you've written out your balanced chemical equation, you're typically going to be starting with the grams of each reactant, which means that you need to convert between grams to moles, because remember, when we do stoichiometry, you're always using moles. And then once you've got your number of moles for your reactant, then you're going to use the mole ratio to do stoichiometry. And for that, you need to evaluate the stoichiometric coefficients, which is why you need your balanced chemical equation. And you're going to use those values as your mole ratio to convert to how many moles of product that you're making. And you do this for each reactant. So we're going to do this for each reactant. Figure out how many moles of product that you're making. So for each reactant, you'll perform stoichiometry and figure out how many moles of product you're making. And then the answer to which one is going to be the limiting reagent is step 4, and that's the one that makes the least amount of product. So whichever one makes less product is your limiting reagent. And if you follow these simple 4 steps, you'll get every one of these limiting reagent problems correct. Let's take a look at an example. If we take a look at this reaction where 2 moles of H2 is combining with 1 mole of O2 to make 2 moles of H2O, we can figure out which of these is the limiting reagent to figure out what is the amount of H2O that we're making in this reaction. So this is a balanced chemical equation where I have 4 hydrogen on the reactant side, 4 on the product side, 2 hydrogen on the left-hand side, and 2 oxygen on the right-hand side. Therefore, we've completed step 1, where we have a balanced chemical equation. The next thing I need to do is convert each of these gram values into moles for their respective reactant. So in order to convert 10 grams of H2 to moles of H2, remember that I need to use the molar mass of H2 to perform this calculation. So in order to calculate this is going to be for every 1 mole of H2 that there are 2.02 grams of H2. And when I perform this calculation, I find that this equals 4.95 moles of H2. If I do the same calculation for O2, remember there are 80.0 grams of H2 that we're told that we have in this reaction. The molar mass of O2 is 32 grams per mole, And this means that there is going to be a total of 2.50 moles of O2. So for that, we have completed our second step where we've converted grams to moles for each of these reactants. The next step is to use stoichiometry to figure out, based on each of these reactants, how many moles of product we're making. So we can start with H2, where we have 4.95 moles of H2. And if I look at the stoichiometric coefficients in front of each of these values, I see that for every 2 moles of water that I'm making, I'm using up 2 moles of H2. And when I perform this calculation, I find that this is equal to 4.95 moles of H2O. And this is based on just how much H2 gas that I have present in my system. I can make 4.95 moles of H2O. If I run the same calculation, starting from 2.50 moles of O2, importantly now, my molar ratio is going to change because according to my stoichiometric coefficients, for every 2 moles of H2O, I'm only using up 1 mole of O2. And when I perform this calculation, I find that this means that I would potentially be making 5.00 moles of water. And importantly, this value is greater than the value that I got when I used stoichiometry to figure out that I could make 4.95 moles of H2O. And this means that which one makes the least amount of product is going to be H2, or hydrogen gas, and that makes H2 the limiting reagent. Because ultimately, 10 grams of H2O means I can only potentially make 4.95 moles of H2O. And therefore, I'm going to have some excess amount of O2 gas present in my system. So that's the one in excess, whereas H2 is the limiting reagent. Now it's your turn. Pause the video now and try this problem independently, and then resume the video to check your answers. In this question, you were told that we're taking 25 grams of sodium, reacting it with 50 grams of chlorine gas to make 2 moles of sodium chloride, or NaCl. In order to determine how much NaCl that you could actually make, we need to identify between sodium and Cl2 which of these is going to be the limiting reagent, or the limiting reactant. And for that, we need to follow this order of operations to get there, and figure out which of these is going to produce the least amount of sodium chloride, because that will be our limiting reagent. So importantly, we already have a balanced chemical equation, where we see that 2 moles of sodium is reacting with 1 mole of Cl2 to make 2 moles of NaCl. Next, we need to convert the amount of grams of each of these reagents into the moles of those reagents. And for that, we can use the molar mass, because 25 grams of sodium can be divided by 22.99 grams per mole for sodium, where we can figure out that we have about 1.087 moles of sodium metal. The molar mass of Cl2 is 70.90 grams per mole, and if we divide 50 by 70.90, we see that that means that we have 0.706 moles of Cl2. Next, we'll use the amount of moles of each of our reactants using the molar ratios to figure out how many moles of product we can make based on each of these reactants. And for the molar ratio between sodium to sodium chloride, it's 2 to 2 or 1 to 1, because we can reduce 2 to 2 down to 1 to 1, which means that if we have 1.087 moles of Na, or sodium metal, and then we use the molar ratio, which is 2 moles of NaCl divided by 2 moles of Na, which again we're just getting from the stoichiometric coefficients, we could find that we could make 1.087 moles of sodium chloride. And now we need to do the same for chlorine gas, or Cl2, where we have, starting with 0.706 moles of Cl2. And now notice that the stoichiometric coefficients are different, where now we're just comparing how much chlorine we need to make 2 moles of NaCl. Importantly, there's an invisible 1 in front of Cl2, which means that we use up 1 mole of Cl2 to make this product, which means if we multiply this value by 2, we get 1.412 moles of NaCl. And notice that this value is higher than the amount that we would have produced if we had just used the sodium metal, which means that the least amount of product that we can make will tell us our limiting reagent, thus completing all of these steps, where we see that sodium is going to be our limiting reagent because it can produce less amount of sodium chloride, which means that we have an excess amount of Cl2 gas. So if you got sodium for this reaction, or Na, you got it right. If you check the description, I have thousands of practice problems that you can check out to help you ace your chemistry class. Drop a comment down below if you have any questions related to chemistry, and make sure that you subscribe to the channel so that you never miss out on another video. I'll see you next time.